You all have homework for me from chapter 2. Okay, so let's keep in our examination of what we get when we look at our data. So we had talked about histograms, and I included in this one the cumulative frequency, that ogive. This is to tell us how much of our data has gone by. Some cases, cumulative frequency is not as helpful as it could be. It's up to you whether you think it's useful for the task you're looking at. And that is data dependent. Again, to create it, we need to use the cumulative piece in the data analysis tool that we were using over here under data. All the way over here on the right, it says data analysis. That's where we find that. That way we can do something like this. But interestingly enough to me, this is the only time I find a line chart useful for frequency distributions. When I see a line graph, I tend to think of it as time. And we look at changes over time. Now that's a bias because that's what I was exposed to most. But when we look at histograms, we can see a lot more about the shape of our data. So here on page 63, I have several different histograms. All of the data in these left three are skewed left. The center, the highest peaks, what we call the modal class, appears over here to the right, and the tail goes off to the left. And as we go from top to bottom, we see in the top one, there's only one real peak. But here in this middle one, there are two peaks. And here in this bottom one, there are actually a bunch of things that there were gaps between. All of that is mirror imaged over here, so these are skewed to the right. And these are symmetric because they look the same on the right as they do on the left. We think of our skew as the direction the long tail goes. So our long tail is on the left or our long tail is on the right. To me, that sounds backwards because the bigger clumps are in the other direction. But I'm not looking where most of my things are. I'm looking where the long end is to measure skew. If we only have one big peak, we call that mono or unimodal data. If we have two or more high peaks, bi or multimodal, and then the gap indicates that we have outliers in these data. Now, we'll actually have to come up with a definition of how far the gap needs to be, how far away from the rest of the data it is for an outlier to truly be meaningful. So if this is a really small gap, then maybe we're making much ado about nothing here. If this is a really big gap, I'm going to want to know what's going on there. But when I go into my Excel setup, I get a bunch of different options. If I say, draw me a picture, insert chart, it gives me a bunch of options. Line charts, again, I think are more useful to time data. You can have them overlap, you can stack them, you can have the data actually appear on them as little dots or not. Columns and bars, this drove me nuts for quite some time. I couldn't figure out what the difference was until the book says, oh, no, column charts are vertical, bar charts are horizontal. I'd never heard that distinction in my entire life. And if you call them both bar charts, you're not going to offend me. Pie charts with exploded pieces if needed. Scatter plots. Now, scatter plots are designed to look at bivariate data as opposed to bivariate data as opposed to univariate data, because we want to look at a relationship between whatever we're plotting in this direction versus whatever we're plotting in that direction. And again, there are all sorts of places where we can do these, depending on what we're after. And different pieces of data are best visualized in different ways. So here, let me share this so it'll show up on the recording. Here, I was given data about housing starts. How many new houses were built in a given year? In thousands. So in 2000, there were 1,573,000 new houses built in the United States, as opposed to tearing down or doing something else. And I'd be looking for a trend over time. What has happened? Gee, what do you see just looking at the numbers? Not always easy to see just looking at the numbers, right? Talk to me, Mike.
Early in the 2000s, it was up there pretty high, and then went low.
Yeah. Right. And if I draw a time series, insert chart, or I go to the insert ribbon, here are all of my chart options. I can create what they recommend. Oh, look, hey, it'll give me a column chart. It'll give me a line graph with or without the dots on it. It'll recommend some options for me. Here's the line graphs. Here are the histograms. Here are columns and bars. I already did this. And I did the data with the dots on it as a line chart. 2008, 2009. That's here. Anybody know what happened in 2008? A little more than just a recession. It was really the housing bubble. This was when the mortgage-derived, the derivative assets crashed in 2008, and the housing market went underwater. And all of a sudden, you had houses that had been mortgaged and remortgaged, and those mortgages had been subdivided and farmed out as like stocks, like they were worth something. Hey, I have a pile of $1 million worth of mortgages. I'm going to cut it up into 1,000 pieces and sell that for $1,000 a piece. Because when these mortgages come due, you'll be able to cash that in. I'll have $1 million. I'll give you the 1,000 based on the number of shares you want. And then somebody else takes a pile of those, says, hey, this is worth $1 million. I'm going to cut it up. And those are secondary derivatives, the derivative market. And all of that was legal between 2000 and 2009. And then the market crashed because people stopped being able to pay their mortgages because of the recession. But it was really the housing market crash that brought about the change in derivative asset pricing. And so there's a lot of financial information right in that picture. Oh, there's the housing crash. And then we started to recover and housing starts went back up. We started to see over time this sort of behavior. Now this as a line chart draws a time series more clearly. As a bar chart, and I could change the chart type here, I could make this a column chart. It doesn't look anywhere as near as nice, does it? It doesn't seem to show any sort of causal relationship. And that's a question. Was there a causal relationship here or not? Is this more useful or less useful this way as reporting information than trying to say, oh, there's some sort of cause and effect going on as we go from left to right? When we look at scatter plots and data that works in multiple variables, I could say, okay, how long have you been a student versus what is your GPA? How long have you been employed versus your salary? Here, we have a plot of life expectancy and birth rate. Now, I don't know, do you think that life expectancy is related to birth rate? Does there appear to be any sort of relationship from this pile of data? Does that seem to cluster anywhere? Does it seem to show some sort of positive or negative behavior? What does that mean? The way in which my data is clustered can indicate whether we have a relationship between these two ideas. Now, I don't know if I've got cause and effect. I might still just have relationship. A positive relationship is whereas one of them goes up, so does the other. A negative relationship says as one of them goes up, the other one goes down. So in that left column, the upper one is a positive relationship. As X is getting bigger, so is Y. And here's a negative relationship because as X is getting bigger, Y is getting smaller. But on the left pictures versus the center pictures, the left picture shows me a stronger relationship because that data seems to be tighter together. And in the middle pictures, the data seems to be further apart. If we were to somehow try and measure how close together or how far apart, we could do that by trying to put some sort of measurement in the middle and then measuring how far away we were from that. Again, whether it's weakly positive or weakly negative, over here in the upper right, I see, well, they say it's no pattern. I don't see any clearly positive direction to this. I don't see any clearly negative direction to this. Here I see a relationship, but it doesn't look like a straight line anymore. It looks like it started out going up and then it started to come down afterwards. We can fit curves to these. There's something called a line of best fit or a regression equation. We'll discuss that in chapter 12 in more detail, and we'll be able to quantify how strong versus weak looks by looking at the distances from that line or curve of best fit. Now, in Excel, it's actually easy to do this. Let's share that one to the recording. Okay, so here again, I have bottled water sales. And I can ask, how much does the price of bottled water affect the sale? Or how much does the number of units sold affect the price? I don't know which is cause, which is effect. Can't guarantee there is a cause or effect here. This might be more calibrated by time of year, right? Oh, I'm not going to sell as much bottled water in March as I am in July. So maybe there's another confounding variable that I don't see here. So we plot data analysis, histogram gave me bar charts. This time, I want a scatter or a regression. So I'm going to do a regression. Is the scatter plot direct in here? No. So we'll do it under regression. Click. Where are the X's? Where are the Y's? Well, here are the Y's. And the X's are here. And yes, I included the labels. So let me put the labels on there. And I want a new worksheet to show me the results. Oh, that's the wrong one. Let's not do that. Let's get rid of that. Let's do it the manual way. Okay. Highlight these items. We'll just highlight the numbers this time. And we'll go back to putting in a chart. Insert. There are scatter plots. I see an X and a Y with a bunch of dots in different places. When I hover over it, it even says scatter. I click on a scatter. Now I can do scatters in multiple ways. I can try and link the data. I can just show dots. If I have more than one trend, I'll get more than one curve. I don't think there's any direct curve here, so let's just do this first one. Do you see a relationship here? Tell me what you see. Aha. As our price increases, the number of units sold goes down. We believe. Now, this is not easily quantifiable here, right? I couldn't tell you by how much it goes down in terms of sales based on the increase in price, but Excel will find that information for me. If I hover over one of the data points and right click, one of the things I can do is add a trend line. That trend line shows me what we see as our negative relationship, right? As we're going from left to right, that line is going down. Now, there are all sorts of other information here. We can do, as I said, we could fit other curves. If we thought that we didn't have a line, but we instead had some other curve, we could put that kind of curve in. Let's ask for the equation. Boop. Well, now, what does that equation tell me? Okay, wait a minute. That's the equation of a line, right? Line has two numbers in it. What are those two numbers? Algebra was a long time ago. I hear mumbling. Somebody speak up. Mx plus b. So m is slope, b is a y-intercept. So if I were to keep backing this line up, I cross the y-axis at 317. Well, what's that negative 120 thing tell me? That is the slope of my line. But let's try and put that in terms of what this problem means, right? This line is measuring sales and dollars, right? And slope is change in y over change in x. I know algebra was a long time ago, that's why I'm reminding you this. Change in y is change in number of bottles sold. Change in x is number of dollars. So that tells me if I increase the number of dollars by 1, I should lose 120 bottles per week. Negative 120 over 1 as a ratio. I can think of that change in y, change in x. I can even ask how strong is this relationship, and one of the things we have in our trend line, highlight the trend line again, way down here at the bottom, I have display R squared value. Now, R was the result of something called the Pearson correlation coefficient. A measure of correlation. We'll talk about it more later, but the closer that number is to 1, or -1. +1 would be going up, -1 would be going down. The closer that is to 1 or -1, the stronger our relationship is. But that's R. This is R squared. Grab your calculators, take the square root of that number. R squared, it's right up there under my equation. What's the square root of that? Closer to 1 than not, right? So this seems to be a stronger relationship rather than a weaker relationship. And again, technically, since when I take a square root, I get both a positive square root and a negative square root, I would say, oh, this should probably be a negative number since our relationship is negative. It turns out that there's a geometry meaning to that R value that we'll get into a little bit later. But the overall behavior, where did this come from? Excel just did a whole bunch of math that I didn't see. I don't know what it did yet. Promise we will eventually. We can do higher, more variables. If I, instead of having just 2 variables, what if I included time of year? Because this is bottle sale, units sold versus price. What if I also included week? What week of the year was it? The first week through the 52nd week. Well, then I would have 3 variables involved, right? Now, I have to figure out which do I think are the cause variables and which do I think is the effect variable. The way I've set this up right now, my cause variable appears to be dollars, and my result, my output, seems to be number of units. As cost goes up, units goes down, because I can control costs easier than I can control how many people buy the water. I can't force you to go buy water. I can say, this is what I'm going to sell it for. And if I wanted to see if number of units sold was also affected by year, I would need it to be a horizontal variable, a cause rather than an effect. So I would try and write this new information in 3 different orders. Instead of just having price and units sold, I'd have another column on the left, week. And then I'd have 3D, right? Now I am absolutely horrible at drawing this. So I'm going to do it with my body instead. You're going to do it as well. Take your finger, first finger, stick it straight out in front of you. Take second finger, stick it out to the side. X and Y. Like I was drawing on the floor, X and Y. Take this picture and lay it down flat. Oh, okay, now stick your thumb up. There's your third dimension. So if I had weeks going this way and cost going this way, I could have price going up and down. Sorry, a number of bottles sold going up and down. So I have week and price, and then I get number of bottles. Now that would be a 3D picture, but I'm a crap drawer, so I would do that here. And there are a lot of ways to do higher dimensional analysis, including taking a 3D picture and looking at it from different angles so that you can see different causes and effects. Even more powerful statistical software, Power BI, Orange, what was the one they provided with this software was the MathStats program that you can actually buy through McGraw-Hill. They all have methods for doing higher dimensional analysis in different ways. I am less fond of doing anything with more variables this way. I think it's much easier to do internal sub 2-dimensional pieces, but that's because I'm having trouble seeing in 3D. By the way, 99.9% of the 3D graphs you will see will use a right-handed system, where X and Y in the positive directions are the shapes you make with your right hand as opposed to your left. Because if you really want this to match up properly, you end up being rude, so don't do that. Use your right hand. I don't know who came up with that idea. Questions? Let me go back and close some of these so I don't have 8 million holding up. Okay. Again, column charts, bar charts are available in the same fashion. I am really kind of annoyed. And now this is where I'm going to start talking about style. This picture on page 76 has the same data, 2 different ways. And all it asks is how often are you on Instagram? But notice it's broken up by year. We have 4 different years here, 2014, 16, 18, and 2020, which to them was current when they gathered this data. Several times a day, once a day, a few times a week, less. Anybody got any idea what pisses me off about that left-hand picture? What's wrong here? And I don't mean wrong as in they did something mathematically wrong. I mean wrong as in it gets like fingers on a chalkboard. Wrong, you shouldn't do that. Well, that's part of it. You'll notice that the bigger stuff is to the left and the smaller stuff is to the right. That's, but even more than that, within each column, the newest data is to the left and the oldest data is to the right. The light yellow color is 2014, the blue color is 2020. That's ass backwards to me. Now, that's a personal issue. Again, I do see the trend they're showing me, but I have to think of it going the wrong way. Because in those columns, time goes this way, from right to left. And unless you're reading Arabic or Hebrew, very few languages go right to left. So it's not automatic that I will see it that way. I'll be saying, I'll look at that and say, oh, Instagram must be going down. No, it's going up. You're just reading the time backwards. We make some assumptions about the way our graphs are drawn. Again, right-handedly, thinking from left to right. Here, it's from top to bottom. But now at least less often is at the bottom and more often is at the top. But the time is still backwards. Because the older data is above the newer data. Whether you do a column chart or a bar chart, to me, is irrelevant. But those are, what kind of data is that? Not what data, what measurement level is that? Is that ratio data? Is that interval data? Is that ordinal data? Is that nominal data? What kind of data is that? Ratio. A ratio happens when I have numbers and 0 means something. But look at the data we gathered down here, because that's what we asked people. We asked people, how often are you on Instagram? And then gave them categories. Do we know the difference between each of the pieces?
Vague.
It's vague, so we don't really know. So that's ordered. That's ordinal, less to more, but the gap between isn't clear. It is in order, but that's nominal, ordinal, interval ratio. The most math to the least math. Nominal. So this is, I really can't do much other than compare. If I ask a question like this, and I want to know what did people actually used as the most important category. These categories are ordered. But what if my categories were simply nominal? Here are some complaints about the concession stands at a stadium. And you'll notice they've listed all the complaints down here on the bottom. And I've got a bar chart. But instead of me putting those in any particular order, the order I put them in was largest bar to smallest bar. So over here, that's the one that had the highest number of complaints. Oh, the food was cold. I spent too much time in line. There wasn't a vegetarian option. All the way down here to there was no chili for my hot dogs and the counter was dirty. If your biggest complaint about the concession stand at this stadium is that the counter is dirty, how many stadiums have you been in where they spend their time wiping the counter? But if you were the owner of this concession stand, you could say, I really only want to concentrate on the top few issues. Okay, now I know what those are. I've identified, and I can even go forward and I can measure and count how much these numbers are. It turns out if you add up these three bars, you get 76. 76% of all of my complaints fall into those first three categories. So if I address those, I'm addressing more than 3/4 of the people who've complained. That's a good investment on my part. This sort of, again, line chart for completion by percentage, our ogive that we saw with the previous data, still applies here, but this type of chart is called a Pareto chart or a Pareto chart. The Italian economist Vilfredo Pareto, I wrote it down, 1906, said, in general, you should spend 80% of your outcomes come from 20% of your causes. Few causes, most of your outcomes. The Pareto principle says, if you address the primary group of issues, you'll satisfy the majority of your customers. And so the Pareto chart here helps me to find that information. Questions? I'm going to show you a chart I hate. And then I'm going to explain to you why I hate it. This is a stacked column chart. Applications to med school over time have increased, yes? The total number of applications is the height of the chart. The red portion of the chart are men, the blue portion of the chart are women. Women's applications are clearly getting bigger, right? Men's applications, are they getting bigger or smaller? They got bigger and then they got smaller again, right? But you couldn't just look at the height of the bars and tell, could you? With the women, you could absolutely just look at the height of the bars and go, yeah, the blue bars are getting bigger. But because they're stacked one on top of the other, you can't tell that this red bar is actually smaller than this red bar because they're not at the same floor level. If I only cared about total and not about breakdown, I just make it one color for each group. But then if I want to compare them, rather than doing stacked bars like this, stacked columns, I'd be better off doing separated columns like this. Again, that's a personal behavior. I don't like them as much. They are useful. Pie charts used to really not be a thing. Do you know who made pie charts a big thing? USA Today. USA Today was the very first newspaper in America published in color. And to emphasize their color every day in the bottom right corner of the front page was a story at a glance, and it was a chart. And almost always, it was a color pie chart. Hey, look, we have color, man. Like the Wall Street Journal every morning has the stock market zigzag on the front of it. But it was black and white. No, we're in color. My problem with a pie chart is that unless it's labeled really clearly, can you tell? Yeah, the purple one is smaller than the red one, right? By how much? Covered up the numbers, it's hard to tell, right? And some pie charts are done in 3D and then blown apart slightly. It's really hard to tell sometimes what's going on with it. Another way to do a pie chart, instead of doing it as a circle, is to do it as a rectangle. That's the same chart. 100% of people. Where'd you buy a book? But again, there's no labeling on relative size. Again, I can see which one's bigger, which one's smaller. It's workable. It's not ideal. Questions? Again, almost all of this is preference. If you're trying to sneak something by, you might want to make a chart that's a little more confusing or a little harder to read. And then you can lie to somebody really well. How many of you have taken Dr. Warfield's Intro to Excel and Small Business course? Oh, okay. Sorry? Oh, good. In Excel, it is very easy to do summary pivot tables. A pivot table, a table is really the easiest way to look at a bunch of data. But a pivot table is an interactive table. If you change something in the data set, you can then refresh the table and it'll automatically update all of those pieces of information. I put an example on our page. Again, there's a discussion here. Where's my list of examples? Pivot table, there it is. So what you can do is you can tell me what pieces of data you want where based on these options. So here are home sales in Gotham. What's the size? What's the type? What subdivision was it in? And you can create some averages, counts by deciding which thing you want in each table. And it'll create it based on this table and this table. It'll summarize all the data. Are bigger houses to be found in Hidden Hills or Oak Knoll or Westwood? Well, I can look at the average of the square feet based on what type of house as well as where it is. And I can create the categories to fit my data. And if something in here changes, I can refresh these tables, it'll automatically update. If I got new information, I could add to the bottom of this table and it would update all of this automatically. In a general sense, pivot tables are very powerful, but clearly it can hide some things well. I can decide what is and what isn't measured. And the more data I have to pick from, the more information I have. Okay. As I said earlier, one of the more important things you can do with a graph is exaggerate, hide, or lie outright. In 1954, a book came out by Darrell Huff called How to Lie with Statistics. It's not a big book. I put the PDF on our Canvas page. It's only about 60 pages. It's not very dense either. But let me think about what I can do in a graph. Here, this picture talks about the average length of a cell phone call. Oh my God, people are talking so much more than they were 5 years ago. That picture is really, really clear. Those bars got a lot bigger over there on the left. I'm sorry, on the right than they did on the left. Yes? There's just one problem. Take a look at the y-axis of that graph. It starts at 2 minutes and only goes to 3 minutes. So these are all different by less than 1 minute. If I actually start the y-axis at 0, I get a very different picture, don't I? Same exact data. All I did was rescale the y to exaggerate the differences. There's barely any difference between phone calls from 5 years ago and phone calls from 2020 and 2021. They're barely a minute different. It's not a huge change. I'm not using a lot more carrier information, but I could do the same thing in terms of changing the X scale. Here is the cost of basic mobile phone service over time, 95 to 2020. Oh, it's not that bad, right? It's gone up every year. It's gone up. It's not gone up a lot, has it? What do you think now? Same exact data. One picture is half the width of the other. That looks like a much more severe increase, doesn't it? But it's the same data. It's the exact same set of numbers. Even if I don't have the same distance here or here, there's all sorts of things that are going to screw with me just by my impression. Clearly, med school applications are going up a lot. I have a lot of problems here. First of all, why is this picture at an angle? Is the 3D behavior of this picture doing anything to help me here? Please notice that the roof of these are pointed down. The roofs of these are pointed up. This is all sorts of screwy perspective, isn't it? And I know it's about med school because it says so right there. Do I need the pictures? Oh, look pretty. You're distracted from the numbers, aren't you? And again, the y-axis starts at 30,000, not at 0. So let's fix this. Let's throw out the pictures, get rid of the clip art. Let's turn this from a 3D picture back to a 2D picture, and let's start the y-axis at 0. Are med school applications soaring? They're going up. Soaring? I don't know. Again, though, is a column chart helpful here? This is time data, right? Maybe a line chart would be more useful. That's a decision to make. As I said earlier, exploded pie charts give me the willies. I'm pretty sure that these colors go around clockwise from noon. So podiatry and plastic are these last two. And I'm pretty sure that plastic is smaller than podiatry, but is urology bigger or smaller than cardioinvasive? Can you tell? So again, we've got interesting artwork floating around this picture that distracts us from what's really going on. We've got bad perspective. We've got an unclear definition because last time I checked, cardioinvasive surgery and vascular surgery overlapped quite a bit because there are lots of blood vessels in the heart. So vascular surgery and cardioinvasive surgery seem to go together. Oh, crud. In in our actual Canvas page. Come on. Handouts. I'm pretty sure I put the Huff book up here. If I didn't, I'll find it and upload it, or at least put a web link to it. Daryl Huff actually uses salary as a question about pictures. I think you'll appreciate it because the same thing happened here. Here's a picture of physician salaries. It's a column chart, right? How does 2000 compare to 2005 on the left picture versus on the right picture? I mean, yes, it's clear this is the same height. This is the same height. But these aren't all the same width. So the visual impact is even bigger because not only did I make it taller, I made it wider. It looks like physician salaries have gone up a crap ton. Well, they have gone up, but the impact is lessened if I make all the columns the same size. So by not only doubling horizontally, by doubling vertically, I have problems and I need to fix them. If you have sources for your data, you need to write them down. What database did you get this information out of? Where did you get this survey from? Who gave you this? Especially if you're publishing this. If you're doing this for an in-class report, I'm sure your instructor is going to go, okay, where'd you get this number? Who gave it to you? If you've got a complex graph, or if you've got estimations in your graph, you have to make notes of those. You really need to make sure that your design, if what you want is to convey information, is as simple as possible. If your design is too confused, make it as complex as you can make it. If you can't dazzle them with your brilliance, baffle them with your BS. Here's a great way to do it. I will quote Mark Twain to you. Numbers don't lie. Figures don't lie. But liars can figure. I would prefer that you act ethically and honestly and as forthright as you can be. So when you go to design or create or look at a chart, I need you to do this analysis. Hey, what's really going on here? But then we actually have to see where do the numbers fit into this. So now that we have visuals, the next thing is to get some actual math done. So on Wednesday, I'm going to start looking at descriptive statistics. We have to be able to describe our information that we gathered in some sort of summary fashion. And that is what we will do next time. I will see you all then. Have a wonderful rest of your day.